In this video, I just want to run through the four-step process for doing a hypothesis test, specifically testing one proportion. So in the state step, we want to define the parameter, state the hypotheses, and state the significance level. So when we're defining the parameter, we want to be specific, refer to the population. So we say the population proportion of whatever in the context is equal to P. So we give that P value is the population parameter of something. Then our null hypothesis, we say P equals some particular value, and this is the null hypothesis value for P is this P naught or P sub 0. And then our alternative would be to say that P is less than or greater than or not equal to P naught. And then we also state our significance level. It's usually given in the problem, or use 0.05 if not specified. Then in the plan step, that consists of stating the inference method you're going to use and checking the conditions needed to use that method. So usually I would check the conditions first and then state, but you can kind of do it either way. So for the one proportion z-test, the three conditions we need to state are random sample or random assignment. We don't just say random check, but it is okay to see that you could say that there is a random sample as stated in the problem. But usually say a random sample of what, or people were randomly assigned to treatment groups, whichever the case may be. The 10% saying that the sample size is less than 10% of the population, or it's reasonable to assume that the population is 10 times the sample, either one of those, with the specific numbers shown in the context of the problem. Remember to only use this when you're sampling without replacement from the population. If you're not sampling without replacement, certainly do not say that you are, because that is not going to be correct. The normal large sample condition, we need to have a large enough sample to use the normal model. In this case, we say n times p sub 0. Now notice it's not p hat like we did with confidence intervals. This is the value from the null hypothesis. Okay, so make sure that we use that. So we say n, the sample size times the null hypothesis proportion is greater than or equal to 10, and then the opposite of that times n is also greater than or equal to 10. Make sure to put specific numbers and to say it's greater than or equal to 10. Then we can say, if once we've checked that all conditions are met, to use a one proportion z-test. So that is the type of test we are going to be doing. Now, the next step is the do step, and we're in the do step. We want to know, is there evidence in favor of the alternative? So the two values that we need to calculate are the test statistic, which is basically a z-score in this case, and the p-value. So basically here, we want to know how likely it is, for example, if this were a greater than, so if we have p greater than something as our alternate hypothesis, we want to know the area under the curve that is beyond our sample statistics. So whatever our p hat is, we want to know the area under the curve. So the z-score tells us how many standard deviations p hat is from p naught. That tells us the number of standard deviations. The p-value tells you the area under the normal curve. So usually this tells me number of standard deviations, this tells me the area under the normal curve, and I see if this area is less, is small enough to reject the null hypothesis. Then our conclusion, we have three parts. Number one, compare the p-value to alpha, use specific numbers, and then say one of two things. Because the p-value is less than alpha, whatever that specific number is, and whatever specific number alpha is too, like 5%, we reject the null hypothesis. There is convincing evidence to support blank, whatever the alternative is in context. Or because the p-value is greater than alpha, we fail to reject the null hypothesis. There is not convincing evidence to support the alternative. Notice we never say, never say, accept the null hypothesis or that the null hypothesis is true. All we can say is that we reject it or we fail to reject it. If we fail to reject it, we don't know that it's true necessarily. We just know that we don't have convincing evidence that the alternative is true. And then answer any question that is asked in the problem that is related to the conclusion. Make sure to specifically say that your decision is because of how the p-value compares to alpha. In other words, link your conclusion to the evidence you found in the do step calculations. And then just a couple of AP exam tips here. When we're checking conditions, there's actually 3 types of AP problems that involve conditions, and what we're doing is doing inference procedures. If we're doing an inference procedure such as a confidence interval or hypothesis test, basically we are checking conditions to verify that we can use that particular inference method. So if you think a condition may not have been met, or you're not sure, and you may say something like, we assume that this is true, go ahead and proceed with the calculations in an inference procedure problem, but note your concerns about the validity of your results in the conclusion. However, if the question is specifically about checking conditions, and usually it's worded, is it appropriate to do this test or this confidence interval? That means they want you to check the conditions to verify to see if you could proceed with the test or interval, and then if one of the conditions is met, you explain why not, okay, why you cannot proceed. Then the third type of question is about the purpose of conditions. These are asking why a condition is necessary. These are usually the hardest of the 3 because by the time you've checked conditions over and over, sometimes you forget why you're checking them. So it's important to think about and study why the conditions are necessary and why you're checking them. Now, for some examples of hypothesis tests, I'm going to refer you to some videos that go along with some textbook examples. You'll find those on the Notes and Videos page, and they're also in the e-textbook in the 9.2 exercise section next to number 39 and number 45. But in those videos, they do a really good job of going through all of the 4 steps, but except for how to calculate the p-value. So I'm going to make a video just about how to calculate the p-value and do those calculations, but everything else is very well covered in those book videos.